This continues our series on interpreting laboratory results for urinary hormones, and today we're going to talk about progesterone and estrogens. So progesterone is unique in a urine profile in that usually you measure hormones themselves in urine because they exist in urine as phase 2 conjugates. And what that means is you don't really measure testosterone in urine. What you measure is the body turns testosterone into a more water-soluble form of itself, which is a glucuronide or a sulfate. So the body might add a sugar-like molecule onto testosterone to allow it to get into the urine, and that's really what you're measuring. So with progesterone, what is unique is there really are no phase 2 conjugates of progesterone to be found in urine, and so what researchers have always done that want to look at progesterone levels is they typically measure this surrogate marker, which is a downstream metabolite that parallels progesterone called pregnanediol. And what that is beta-pregnanediol, and there exists an analogous allo or alpha-pregnanediol. And so progesterone is metabolized primarily down these two pathways. So over 75% of progesterone goes down these two pathways. So if we can look at the primary metabolite from both pathways, we can get a really good idea of what the progesterone levels are. In some women, they may favor one metabolite or one pathway over the other. And so if we look at them both in concert, then we can kind of see what the progesterone levels are doing. And so what we're looking at when we say progesterone here is a weighted average of those two pathways. And you can see for this particular woman, she's right on the lower end of the reference range. And so we're going to want to look at that and also look at that relative to what her estrogen levels are doing. And as the estrogen levels in a relative sense get higher than the progesterone levels, then we might start to see some symptoms of estrogen dominance. And so we're going to want to monitor that. And so when we look at estrogens, we've got more than just a couple metabolites to look at, and we really want to break this down into two parts: the primary estrogens that sit on the top of the pathway, and then the metabolites that sit at the bottom. So if we look at the primary estrogens, we're looking at estrone, which is called E1, estradiol, which is called E2, and estriol, which is called E3. So the most potent estrogen that you have, both men and women alike, is estradiol. And so typically when you're measuring estrogen in blood or in saliva, you're usually only getting an E2 value. Sometimes physicians will measure the others. But in urine, we want to look at these three kind of in aggregate to see where is a patient relative to the population. You can see this woman, it's a pretty clear story that she has low levels of estrogen, the estrone being significantly lower than the reference range limit. The same with estradiol, and then yet again for estriol being low. So she's relatively estrogen deficient. So once we've looked at that question of estrogen status, then we can move on to the metabolism picture. So estrogens are metabolized down three primary pathways: 16-hydroxy pathway, the 4-hydroxy pathway, and the 2-hydroxy pathway. And these are not equal to each other. The 2-hydroxy estrogens are considered protective. They're sometimes called the good estrogens, whereas the 16-hydroxy estrogens are sometimes called the bad estrogen, because it's a more potent estrogen. And in reality, the very bad estrogen is the 4-hydroxy estrone, as well as 4-hydroxy estradiol, reason being that these can actually cause DNA damage, which is why they're considered carcinogenic. And so what we want to look at are two things. One is the relative distribution of these three pathways. So we can see in normal estrogen metabolism, about 71% goes down the 2-hydroxy pathway, 9% the 4-hydroxy pathway, and about 22% the 16-hydroxy pathway. So you can see for this particular person, their 2-hydroxy estrogen is significantly higher than what's typically expected, and then the 4-hydroxy and the 16-hydroxy estrogens are underrepresented. And so that might be considered a favorable distribution, since the 2-hydroxy estrogens are again considered the good estrogens. Now once this process has occurred, then these hydroxy estrogens, particularly the 2 and the 4, can be methylated. And this is considered a protective step. So we're going to make a methoxyestrone. And you can see for this particular person, she's within the normal range for the 2-hydroxy estrogen, yet her 2-methoxy estrogen is quite low. So when you look at that methylation activity, this index, you can see that she's relatively low in terms of how well she is methylating estrogens. And these concepts are important not only for women but also to some degree for men, because these DNA damaging estrogen metabolites also play a role in prostate cancer and some health issues for men. So we want to be paying attention to those, particularly in the women, but also to some degree in the men. So if we compare two women, this is one woman's distribution. Again, the one we were just looking at, really good 2-hydroxy pathway, but then low methylation, compared to this woman who's very underrepresented. Again, looking at normal 2-hydroxy estrogen pathway covering about 70%, and this woman's slightly less than 50. So there are things that your practitioner can do to help increase that 2-hydroxy pathway if that's a concern. For this particular person, she's actually methylating those hydroxy estrogens well. So it can help you focus nutritionally on what we can do to make that estrogen metabolism a little bit more favorable. And again, this is going to be relevant not just for female patients, but also for some of the male patients as well. So if patients are watching and have questions, please do refer those back to your provider with respect to your specific results, and then do also see our other educational videos on more specific topics such as androgen metabolism, the adrenal profile, and we hope that these will help you in your understanding of hormones in general and your results as well.